we've looked at the idea of infinite limits. Now I want to talk about the idea of limits at infinity. They're related in some ways, but they're definitely two different ideas. Now, what we want to get out of these next several videos is we want to understand the difference between infinite limits and limits at infinity. And we want to be able to describe what's commonly referred to as the end behavior of a function. So let's go. Limits at infinity different from infinite limits in that limits at infinity describe the behavior of a function as the independent variable becomes arbitrarily large. Hence the reason we call it the end behavior of a function. So let's just consider a function such as f of x equals 1 over x. We know this function has an infinite limit because we've looked at before when x approaches 0. If I graph this very quickly here, we all know that the function looks like this. And as x approaches 0, we have an infinite limit. But what happens as x goes to plus and minus infinity? What happens as we go this way on the x-axis or this way on the x-axis? Again, this would be an infinite limit. Whereas this would be a limit at infinity. So in this particular example, what happens is the limit as x approaches infinity of 1 over x equals 0. So asymptotically, this approaches 0. It never equals 0. It never touches this line. It's always slightly bigger than 0, but asymptotically it goes to 0. And likewise, the limit as x approaches negative infinity of 1 over x is also 0. As I approach negative infinity, the value is actually always negative, but it approaches 0, so the limit is 0.